Hello. In this video we will be creating a better structure for this linked list program. In the last video we created this thing like this. So first we created the node object, initialize its values, and then we added it to the list. In this video we will create functions to do all of these things, so it has a better structure. The first thing we would like to do here is that we would like to create a function which will create this node and initialize its values. Here in the last video we did these 3 lines, so we will wrap around this with a function now. So in this code we have this node again here, the node struct again here, and we will move this root to be a global variable here. Here we had it locally here. The reason I'm moving it to the global scope is because all these functions will now use it so they can all easily get access to the root element, which is the important part. It's the start of the linked list. One might even call it is the linked list. So because this root is the starting point of the list, so it's kind of the list. So these functions can get access to this root because it's a global variable. So let's go and see what we have here. This create new node, it takes this value as a parameter. Value meaning that if we go and look at this linked list, which is here. So the value was this value here, so 527. It's the value of the element. Like if we want to, let's say we want to have a list with values 5, 8 and 10. This 5 is this value here. Okay, so first in this function we will create a new node, and I will save it to this temporary local variable, and we will set the new nodes next to nil because it's not pointing to anywhere, so it's good to always to initialize to nil so it doesn't point to a random memory location. And also if this is the last node in the list, like here the node 3, so it's automatically correct because the last node must have next with the nil value. And then the value will be set what is given in this function. We will set the value for this node here, and then we will return this new node to the caller. So we could use it here like this. We can say node, just let's say node 1 is create new node, and let's say we want to add number 5. So now node 1 is pointing to this new node. So it's quite nicely here. So we don't need to deal with all these things. They are done inside this function. Okay, but we can't do much with this function yet. We need more functions. Let's see what is the next function waiting for us. The next function will be insert front. So I will copy this, and then the header of this function also I will paste it here so all functions can see this function. Okay, so what is this insert front doing? It's inserting an element. It's inserting a value at the front here. It's inserting an element to be the first element in the list, and it's taking taking an argument which is the value which we want to add. Like here, let's say here we want to have a list with 5, 8 and 10. So what we could do here is that we could call this function insert front with first with the value 5. So this would add 5 to be the first element of the list. If we call this again, let's say 8, now 8 would be the first. Now it would be like 8, 5. Obviously we are doing it in the wrong order. If we want this one, we will need to start from the end, because it's always adding to the front. So we do like this. So now we would have exactly this one. So this function takes care all of these nodes. So we don't need to take care of the creating the nodes. This function creates the nodes and behind the scenes kind of. So let's see what this function is doing. First, this function is creating a new node using this function which we just created. It creates a new node. Actually, I think it's a good idea here to look at it here, what we are doing here. Let's say here we want to create a new node and put it at the front. What would we do here? Let's say we want this number 4. So we need to create a new node here, this new node, and this line is doing that. And with the value, with a certain value, let's say that we want to create it with a 5. So let's now take this out. Let's say we want to add a new node with the value 5. So I put 5 here. The 5 goes here, and then this line starts, and this function here will create a new node with value 5. If you go and look at the picture, so this value will be 5 instead of it's 33, but it's in this example it will be 5. So it sets this value to 5, and as we remember from this code here, it sets automatically the next pointer to a value nil. And that's it. And then we save this the pointer to this. We save the address of this new node to here. So new node here is pointing to the new node, and then we set the new node next to be the value of the root. Why is this? Well, let's see here. This is because new node next set the root, because root, the value of the root is at the moment the address of this first element. So root is at the moment pointing to the first element, but now we want this next to point to this element, because this will be now the second element in the list. This will be the new first element, and this will be the next second element of the list now. So this next needs to point to this one, something like this. This next needs to point to the old first element, and this root is currently pointing to the first element. So we are setting these new elements next to be the old root value. And the next thing we need to do is that we need to set this root now pointing to this new element, so that this connection is not anymore there, and we are doing it right here. So we are updating the root to point to the new element, and that's it. And then I will take out these. And what is next thing to do? Again we can insert from, but we can't see any results. So let's next add a function which will print the list, so we can see something. So next function will be print list. It will print the whole list, all the values from the list, starting from the first to the last. And what's happening here is that first we will create a temporary pointer which will go from the first to the last, which will be pointing first to the first node and then to the second node and so on. So the first, it's a kind of cursor pointing to the first, to second, and so on. So first it will point to the root node, and this root was the global variable which holds the address of the first node. So first it will point to the first node, and then we will loop this until it's nil. Until this becomes nil, then we know that it was the last node, and we can stop. So we will print the value of that node. For example, here first it's the root, and root is pointing to the first node, and we will take the value of this first node and we will print it. And then we will update the current to go to the next node, because this next is pointing to the second node. So current is now pointing to the second node, and then we go here. This is still true, and then we will print this value here, the value, and we will get whatever is here, and we will update current to be current next. Current next is now this one, this value here, which is the address of the third node. So now this current is the third node, and we go here, and this is still not nil. So we go inside and we will print this current value, which is in this case it would be 17 here, and then we will update current to point to the possible next node. But now this next node here, the value of the next is nil, which means that that's the last node. So nil goes actually here, so current is now nil, and this becomes false, and the loop ends, and that's it, and it will print all of them. So let's check this, it works. Let me use these values here, 5 to 17. So if we are using insert front, we need to start from the back. So insert 17, and then we have 2, and lastly we have 1. And then let's call this print list. Okay, I will compile this. Succeeded. Very good. Then we will run this, and there you go, 1 to 17, which is correct. Okay. And what is the next function? We can have a lot of functions. You know, we can have a function, for example, get size of the list, which will return the size of the elements. Like in this, we have 3. I don't have it yet now, but we could create all kind of functions. So let's see what we have next. We have next I have here that find last node. Okay, let's go and see what it's doing. I will put it here. Find last node. It finds the last node and it returns the pointer to the last node. It finds the last node and returns the pointer of it, which is the pointer which is pointing to the last node. So why we need this? Well, we need this because if we, for example, if we want to add a node to the back, we need to first obviously go to the back and then add it there, because that's how a linked list works. The linked list basically only knows the root. So if we want to add something here, for example, one item after node 3, we need to travel all the way like this. We need to go here and then add it here. So that's why we need the function to find the last node. So how does this work? Let's see. First we are checking that if the root is nil, then we return nil. This means that if root is nil, what does that mean? That means that if the root is nil, that means that there are no items in the list and the list is empty. That's the only situation when the root is nil. So if the root is empty, meaning there are no items, we just return nil pointer so that the caller knows that the list is empty and they can test whether the list is empty or not, and they can do action accordingly. Okay, if the list is not nil, meaning that there is at least one item or element, then we go here. So again we will set the current pointer point first to the root. So this is the cursor pointer, kind of cursor pointer, which runs from node to node. So first this current is pointing to the root node, and then we say that while current is not pointing to the last node, then just move it to the next node. We have done this kind of run before, so we just one more time quickly. So first we say that while for example here current is pointing to the root and current next is here and it's not nil, so it goes inside here and it updates current to current next. Current next is this one, so now current has the value of this one, the address of this second node, and it's not nil, so it goes inside this while loop and it sets current to this next, and so on. We have done this before already, so obviously when it reaches this one, the current becomes nil here and this loop ends. And now when the loops end, the current is pointing to the last element. In this example it will be pointing to the node 3. So we are just returning the pointer of the last node to the caller. And at the moment we can't use this function because we don't have any functionality, so let's go to the next function. Well, the next function is using it because we are adding an element to the back of the list. So let's go and see what is this function doing. So this is the last function in this video, and then I will stop this video and we will continue in the next video, but let's finish with this one. So add back wants to add an list element to the end of the list. I put the header at the top. Okay, add back. Again, we are not interested in dealing with the nodes, so we want this function to deal with the nodes, and we are only passing the value which we want to add, which we really want to do. For example, let's say we want to add here another element, say 55. So what we want to do here is really we want to call it like this: add back the value 55. That's how we want it to work. We don't want to send any nodes or anything here. We want this function to deal with the nodes. Okay, and it will. So the value goes here, and the first thing we want to do is that we want to find the current last node. And this function is doing it. We already gone through this. So this function finds the last node, and we will save it to this last pointer. And next thing we're gonna do is that we have to create the new node. Obviously, we are creating a new node with, let's say, number 4. We have it here. So I will this one. Let's say we create a new node. Let's say this one, and we will save the address of the new node here. Add the new node to the end, and then we are doing a little bit checking here. We are checking that if the last is not nil. Okay, the reason why we're doing this is that there is a one special case here, because what if there are no items before? Let's say that the list is empty. If the list is empty, it will be simple, this whole thing. If the list is empty, we just set it to the root. If there are no items, then just this root needs to point like this. That's the only thing we really need to do here, that the root we set the root to point to this just created element, and that's it. That's all we need to do here. And then we just set always we will set the last elements next to nil, because this will be the last element, so its next needs to be nil. Okay, if it was not if the list was not empty before, meaning that there is at least one element, then in that case we are going to do this line here. We are saying that the last element next needs to point to this new node. Let's see what happens here. So basically what we are doing here is that we are saying that this next here needs to point this one. That's what we're doing here. That it used to be nil, but now it needs to point to the new element. So this is the address of the new element. So we are setting this next to be the address of the new element. And in both of these cases, we always set the next of this new element. This one, we will set this one here nil. So this not anymore nil here, but nil is now here. Okay, and we can quickly test this add back here. Okay, let's print list and then add back. So that's the old list, and now we're adding back, let's say 215, the year of this moment. Let's add back 215 and then print again. Let's see what happens. Okay, succeeded. Okay, let me run this. Okay, and there's the first list there, 1 to 17 and 1 to 17, and 2015 goes to the end of the list. Okay, that works. Okay, and this one ends this video, and I will continue explaining more functions in the next video. You're welcome to come and see that one if you want. Okay, thank you very much. Bye bye.